Hi, all of you. Good evening. Good afternoon. Online, offline. Okay. Yes, hello. Alihan, Serval, Chanchal, Shikha, Akshatya, Neelam, Akash, all of you. Yeah, good evening. Good afternoon. I'm good, Isha. All nice. Okay, now, I think all of you have now got the full range of questions now. About 20 questions मिल चुका आप लोगों को. कब चेक किया आपने last? Check karo. I think we have done that yesterday evening itself. 10. Okay, I'll confirm in few minutes. Wait. Okay, Nida. I think some confusion there. I've sent for a word. Just give me some time. We'll get back to you. Okay, fine. Right then. So we are with climatology. It's just that we started the first day with some bit of orientation. So I'm running behind by almost 2 questions, not much. Upload nahi hua hai 20? Yeah, okay, fine. So I'm lagging behind by 1 or 2 topics. Yes, Ashwarya, that's my first discussion here. So all of you watch. Yesterday we had a problem with the power supply. So it's like this. Yeah, please. Say these lines are depicting the isobars. I'm discussing gradient winds and the vector diagrams. Okay, the diagrams, the forces, how they align. So close lines means it is relative high pressure and this is low pressure. So say the pressure here is, I'm giving arbit numbers, 1100, say 50, say 1000, 950, 900, and so on. You take up, say, this position here. So this line, if I compare with this line, this is high pressure and this is low pressure. 950, 850, it's a low pressure. The winds will move like this. They should move like this. But because of Coriolis, they might get deflected, वो अलग बात है. And if I have a geostrophic balance, this is the Coriolis force, and this is the geostrophic wind. This happens when we have belts of high pressure and low pressure. Now imagine this one becomes localized heating. So ये 800 लंबा line नहीं रहेगा. It probably will shrink into a small circle here. Because of this 900 will wrap around this. This 950 will wrap around this. This 1000 wraps around this. Okay, so if this becomes a strong heating center, okay, so all the pressure patterns with the low at center will turn like this. So what you will get is something of this kind. So the center is, okay, probably 850. The center is 850, and we have 850, we have 900, we have 950, we will have 1000, and so on. And the vector diagram is that this was a straight line. This was Coriolis. The wind should have gone like this, but the wind has now turned like this. The wind has turned like this. So this turning is possible only if something is pulling it inside. So if this is the PGF, I have a force along this. This is the centripetal force. And this one is, as usual, your Coriolis force. Okay. So that's how I'm saying that in case of this is cyclone. In case of cyclone, okay, the centripetal force, which is towards center, is weakening the Coriolis force. Okay. Right now, Coriolis force and these two are matched. ये ऐसे घुमा कैसे? How it has turned? It has turned because the Coriolis has pulled and brought it here. But if I have an additional centripetal force, okay, so this Coriolis से ज़्यादा powerful is PGF and centripetal force, and that's why it has turned like this. So now what we have, यहाँ पर क्या है? The PGF is equal to centripetal force, Coriolis force. In this case, the PGF, okay, is now more than Coriolis. Why? The PGF is supported by centripetal force. That's why we are calling this as the subgeostrophic. The geostrophic wind is when the Coriolis becomes powerful and powerful and powerful and powerful. Okay, it is now balanced. A condition where the Coriolis is no longer powerful to bring it here, it is less powerful. That's why I use the word sub. Sub as in less. Coriolis is less powerful, so it is subgeostrophic wind. In case of an anticyclone, okay, the high pressure becomes localized. Wrapping ऐसे नहीं होके wrapping ऐसे होगा. Okay, because I have strong cooling here. I have strong cold conditions here. In this case, this was strong heating. So wrapping is like this. If I have got strong, say cooling here, the wrapping is now like this. So this line becomes center. Around this 1050 wraps up. Around that 1000 wraps up. Around that this wraps up. Now when this happens, say the Coriolis, the pressure gradient always is from high towards low. So now if the wrapping happens, if the wrapping happens for an anticyclone, how will the wrapping look like? Now this is the center, say this 1100. Around this, I will have 1050. Around this, I will have 1000. Around this, I have 950 and so on. But the force is always from high towards the low. Okay, so it'll always be high towards the low. So यहाँ पर high है. So high towards low is like this wind. So this wind, while going like this, Coriolis, the wind turns like this. So right now, balance kya hai? Balance is PGF like this. This is Coriolis and this is geostrophic. The PGF continues to be from high towards the low. But ये ऐसे घूम रहा है, मतलब क्या है? Something ऐसे खींच रहा है. When it's pulling like this, so now the balance is, this is PGF. In the opposite direction is Coriolis. There is an additional pull of centripetal towards center होगा हमेशा. So ऐसे हम along this दिखा दें. It's along this, opposite to PGF, and the wind has turned like this. In this case, the Coriolis has become more powerful. In this case, what? Coriolis is as powerful as PGF. In this case, Coriolis more powerful. That's why we call this as super geostrophic. So subgeostrophic is, geostrophic is this. Subgeostrophic, the Coriolis is relatively weaker. So ऐसे घूमा. In supergeostrophic, this is more powerful. So नीचे घूम गया. I hope you have got understood the concept now, all of you. Localized high or low pressure induces okay, that way. Yes, Pranjit, correct. The question is, so why does it turn? It turn क्यों हो रहा है? The turning is because of local heating or local cooling. If the heating is along a latitude, these are the belts of pressure. If the cooling is along latitudes, it's a belt of pressure, what we call as zonal patterns. Now this is a local heating. One small area becomes hot. Okay, so around the small area hot, this has turned like this. A small area becomes very, very cold, Siberian high pressure. So this has now turned like this. So gradient wind, these are the 5 important points. Yes, tell me. Which one? So when we say gradient winds are cyclostrophic winds. Cyclostrophic mean wind ka matlab hota hai, they are rotating systems. Any gradient wind is a cyclostrophic wind. It is a rotating wind system. Ghoom raha hai. Okay. So this is because of localized low pressure or localized high pressure. Okay. So in this case, the geostrophic condition or the geostrophic balance is modified. इसी diagram वापस आएंगे. This is the geostrophic balance. What I'm saying is the geostrophic balance is getting modified. कैसे modified? Okay, so this is turning like this or it turns like this. Okay, so in a gradient wind, it is the geostrophic balance modifying. What I'm saying is that in gradient winds, therefore, it is a special case. These are special cases of a geostrophic winds. Gradient winds are special cases of geostrophic winds. So what does the special case mean? So if there is localized low pressure, this is, okay, this will have cyclones. Okay, because of this, the pressure gradient force is stronger than the Coriolis force because of the additional centripetal force. So PGF jo hai, okay, the PGF or other way around, say the Coriolis force, skulta likho aap. So the Coriolis force is not as powerful as PGF. The PGF, there is an additional force called as the centripetal force. The PGF chota hai. That's why we call this as the subgeostrophic. If you have access to your systems, can you quickly check and tell me if the other 10 answers also are uploaded online? If you can do that. We had done it yesterday, but for some reasons, it was not reflecting. Done? Chalo, karke dekh lena. Maybe towards the end of the class, I will have a look again. Yeah, it should have been 10 plus 10 now, or 10 plus 12, whatever. So maybe you'll have to refresh it, that's why. ठीक है? ठीक है. आप देख लेना बाद में. Come back here. Is this in your notes, all of you now? And you'll draw the diagram. ये वाला. This diagram. Okay? This diagram where the PGF is like this. The centripetal also like this. And the Coriolis is relatively weaker than this. Thus we call this as subgeostrophic. Now the other one I said is the, okay, this is the first case. First case is localized low pressure. The second case is the localized high pressure. In the localized high pressure, so ulta likhenge aap, it's an anticyclone. In this case, the PGF, okay, is less compared to Coriolis. This is an anti-cyclone. Isme the Coriolis force is more than the PGF because this is strengthened by the centripetal force. It is strengthened by the centrifugal force. Shweta, yes, you should know what a reference take. If you take centrifugal, then you talk about PGF strong hai ya weak hai. If you take centrifugal, you talk about whether the Coriolis is strong or weak. The same things, there's like opposite ones that we have. For every centrifugal, aapka centripetal bhi hoga. Okay, so in this case, the Coriolis force is strengthened by centripetal force. The other strong ho gaya, we call this as super. Basically, what happens is super geostrophic. The question is, sir, geostrophic समझ में आ रहा है, हम इसको सब geostrophic क्यों बोल रहे हैं और इसको हम super क्यों बोल रहे हैं? That's the question I'm trying to answer. Okay, geostrophic समझ में आ रहा है where PGF is equal to the Coriolis force. Okay, remember, this balance is not because okay, the PGF becomes more. It's because the Coriolis force becomes more. Okay, so PGF the constant hai. Because of very high speed, the Coriolis increases. So when you say subgeostrophic, you're saying Coriolis has become weaker. When you say supergeostrophic, the Coriolis has become stronger. To understand that, इसीलिए for sub and super, I said talk in the context of centripetal and not centrifugal. That makes your answer a bit more understandable. Harshita, I think I have done it now. In the subgeostrophic, this is subgeostrophic. Subgeostrophic, okay, PGF is strengthened by centripetal. इनके दोनों के comparison में Coriolis is weaker. Just draw this one. Okay, Harshita. Okay, so PGF and centripetal in one direction, Coriolis ulta hai. So the centripetal is making the PGF stronger. You should know how to mention that. And in case of okay anticyclone, okay, towards Coriolis you make the centripetal. The centripetal is making Coriolis stronger. In this case, the centripetal is making the PGF stronger. Did I answer your question? Beta, aap pooch rahe the? Done? Okay, revise this much, that's good enough. I don't think you should go beyond this. Like I said, they'll not ask a straight question. Okay, but use this wherever you can in discussions of cyclones. Agar question paper में इस साल पूछ दिया geostrophic winds, so very much possible they are going into deep details of some of the concepts. Okay, wait. All good here? Can I move on now? Okay. Now, I want a quick discussion on 2-3 topics. देखो आपका question paper देखोगे ना. One is last 3 बार से they're asking about winds and the forces. This is a popular question. Second, air mass and fronts are pretty common. The third, they have been asking questions on climate change and impact type. And the fourth is cyclones are always going to be important. So winds, forces, ye ho gaya. Climate change, impact in different ways, and hydrological cycle, ye maine kara diya. I'll do some discussions here. Okay, something on cyclones, air masses, and fronts. In terms of concepts, I don't need to add anything more. You must know how to write if I ask a question on these. Okay? So let's start off one by one. Yeah. So let me take up temperate cyclones. Temperate cyclone. Tropical cyclones में कुछ खास करना है नहीं आपको, okay? Tropical cyclones, the reasons, the 5 factors of tropical cyclones, heating, water temperature, upper tropospheric divergence, weak wind shear, a strong force of Coriolis. I hope all of you know that. Okay, and it happens in late summers. It will not happen in areas of upwelling. You know all of that. And how does it look like? A very large cumulus cloud. There is an eye wall. The zones of rainfall, the eye wall. We have a very inner cyclone. We have an annular part. We have an outer cyclone. We have an peripheral cyclone. So those you must know. And you can talk about the tracking, how they move along the trade wind belts and whatever we have discussed. All of you must have the basics. So tropical cyclones में मुझे कुछ add नहीं करना है. Okay. All you might add is maybe tropical cyclone, okay, say management. That could have been one small discussion. But that's more of GS, largely around the disaster management cycle. So warning systems, evacuation systems. Okay, talking about managing the storm surge. Okay, so those questions. Mangrove forests on the coast. So tropical cyclone ka management. This could be one addition. Take off from GS. Aapke classroom mein hona chahiye as a part of disaster. Yes, you can do that. Let me come to temperate cyclones. Now, this is an interesting discussion here. Now, see, the facts about the cyclones you should know. Facts may, okay, what is the cause? What is the size? What is the wind speed? What does the structure look like? And what are the locations? ये आपके broad heads हैं. What are the causes? Size, thousands of kilometers. Wind speed, 40-50 के range में होता है. Rarely more than 80 kilometers. Okay, structure, 2 fronts, cold front and a warm front. Warm front ahead, cold front behind, is rotating. And the locations, कहाँ पर होगा? Mid latitudes. And those locations of Great Lakes, Aleutian Low, Icelandic Low, Baltic Sea Low, Barents Sea Low, Barents Sea, yes, Low. You also have influence of Colorado Low, Alberta Low. So I presume you know the locations where this happens. And maybe add a few lines on how temperate cyclone also impact western disturbances. Okay, west disturbances, because ab news mein hai. Okay, western disturbances are temperate cyclones. And they were responsible for the rainfall of 2023. It's an El Nino year, but for good 2.5 months, we had got very good rainfall, June, July. Because of, so add this. I mean, this is the current affairs part you can add. Okay, the unusual heavy rainfall in the rainy months of 23 summer monsoon rainy months was because of western disturbances, which are temperate cyclones. This is one addition up add karoge. Now, In terms of causes, let me add something. What is the cause and what is the mechanism of a temperate cyclone? Okay, so most of us know that these are dynamic systems. They are related to upper tropospheric polar jet streams and Rossby waves. And you can go on and explain it. But then there are other, okay, you can say discussions also. So one of the earliest model was Fitzroy's model. Fitzroy. Fitzroy as early as 1860s की बात कर रहे हैं. Now, in the times of Fitzroy, they did not know the concept of air masses. Okay, but Fitzroy had mentioned that temperate cyclones are because of air and winds of contrasting temperature and humidity properties interacting and creating instability. He did not know air masses, but he was hinting at the concept of air mass. So Fitzroy model says the temperate cyclones are because of air and the winds. Keep writing. Because of the air and the winds of a contrasting temperature and humidity properties. Air and the winds of contrasting temperature and humidity properties interacting and creating instability. Interacting and creating instability. You can add a point here that this was much before the concept of air masses. The idea jo ho raha hai, this idea was given much before the concept of air masses. Air masses could be considered as the earliest model that referred to front-like formation conditions. Fronts-like formation conditions. He had referred to, next point, Fitzroy had referred to how tropical, warm, moist, and less dense air, it referred to how tropical, warm, moist, less dense air interacting with temperate, cool, dry, temperate, cool, dry, and more dense air, could trigger cyclone formations. Okay, so his Fitzroy model was one of the first models that is referring to the possibility of an air mass and fronts. But वो term air mass fronts बहुत बाद में use हुआ. 1920s onwards, when Jerkins came in, they started talking about air mass and fronts. A good almost 30-40 years before, or maybe even more, 60 years before, okay, the concept of air mass was given. Fitzroy's model. The second is Abercrombie's model. Abercrombie, C-R-O-M-B-Y, Abercrombie's model. Okay, now this was the first mathematical model. It was more of a quantitative approach to explain. It was a quantitative approach. It was a mathematical model to explain how contrasting winds and air interaction how contrasting winds and air interaction could create cyclones, could create temperate cyclones. So this was a bit later, 1880s की बात कर रहे हैं, 70s and 80s. So he is building on what Fitzroy had told. The two air masses can come in and they interact and whatever, but they didn't use the word air mass. A third model was given by Shaw, S-H-A-W. Now, Shaw talked about how upper tropospheric winds and dynamic conditions, upper tropospheric winds and dynamic conditions can create a dynamically induced low pressure. Okay, how the upper tropospheric winds, how the dynamic conditions of upper troposphere can induce dynamic low pressures, which can trigger the temperate cyclones. Trigger temperate cyclone. Shaw's model. देखो ये भी सही है ना, right? Isn't it? Now we know, yes, the jet streams play a role. We know Rossby waves play a role. And much before the idea of Rossby waves got crystallized, वो कुछ कह रहे हैं about how they can be formed. Now, these three models, which is Fitzroy's model, second is Abercrombie's model, third is Shaw's model. All the three models, we call these as anti-convective models. They're called as anti-convective models. Because the rising of air is not related to convection or warming of the air. See, essentially, how does the air rise up? This is the question. Why this low pressure is formed, which can pull in the winds from all sides and rise rapidly. So most of us know that this low pressure can because of heating. Okay, heating hai, so convection rise hai. But in mid latitudes, we don't have convection. We do not have, in fact, temperate cyclones in the mid latitudes, okay, are in the winters. How can winters, and the more frequent winters, how can winters have convection conditions, correct? So all the three of telling them, dynamic low pressure hai, not because of heating. This interaction, something like fronts, they are saying, again, nothing like convection. That's why these three models are considered to be root models of anti-convection concepts of temperate cyclone. ठीक है, ये इनका roots हैं. Then we have the more important, ये 1920s में आया, okay, the Jerkins model. The Jerkins model. Jerkin models, इसी में you also add the idea of wave model. So they have talked about air masses, they talk about the fronts, they talk about the Rossby waves and the polar jet stream. उसके बाद you have the notes आपके पास जैसा है. See, what I am anticipating is, most of us can write a comprehensive theory on what are temperate cyclones, how do they develop, discuss the stages, the weather, आप लिख लेंगे. But if I ask you very specifically, discuss the genesis of temperate cyclones, उसके लिए अगर पूछा 20 मार्क में, say 2.5 pages, you are trapped. इसके आगे क्या लिखोगे आप? Most of you will end up explaining air masses, fronts. Okay, so see, if you look at the question paper, they are not asking the theme in generic anymore. They ask a very specific part. कि यही समझाओ मैं, nothing else. Just tell us, don't tell me all about the local winds. Tell me exactly what are the 5 factors that create local winds. तो आपको factor यहाँ से निकालना है, यहाँ से निकालना है, यहाँ से निकाल के जोड़ के the answer has to be ready. That is the challenge of the depth, what they're asking. Nikita, ultimately wave model, okay, includes that. So to start off with, okay, the low pressure ke bahut reasons hain. I'll come to that. Give me 2 minutes. So this you can write down and you can continue. Okay, now temperate cyclone, there are 2 parts to the temperate cyclone concept. One part is the development of fronts. The second part is the development and the trigger of the low pressure. Nikita, answering your point. No, Nashit. It can't happen in advanced classes. Stages of cyclone, okay, the weather, this is your base content. But a vote hange to fir, okay, I will not be able to move at all. That you know. I'm only adding some terms beyond what you know. Okay, keep your exam ready types. So, Nashit, I cannot do that. But look at this. Temperate se 2 part hai. One is the fronts development. Second is the low pressure ka trigger. Shuru kaise hota hai. The fronts development because of air mass contrast. Okay. The fronts development, okay, because of the seasonal contrast between continental polar and maritime tropical. The fronts development, okay, related to the difference in the source regions of the air mass. We can all discuss this. So the continental polar, ye Siberian wala hai. The maritime tropical, either Atlantic or Pacific Ocean wala hai. The CP could also be the Canadian one. It could be the Arctic one. So the source regions can decide the contrast and the interaction. You can go on there. Second part is, how does the low pressure develop? This low pressure development, there are, okay, 2 mechanisms or 2 ways how the low pressure can develop. One is the low pressure develops as a consequence of the meandering polar jet stream, okay, or the meandering Rossby waves. I believe all of us remember this. Meandering Rossby waves. On the right hand side, high pressure, left hand side, low pressure, high pressure, low pressure, aloft. ये ऊपर के height में है. In the above heights, high, low. अगर यहाँ पर high, यहाँ पर क्या होगा? Low pressure. अगर यहाँ low है, surface में क्या होगा? High pressure. Is high, surface में क्या होगा? So this high pressure, because of the meandering Rossby waves, will create and these becomes the trigger points for the interactions. So that's one. Second is that some of the low pressure centers could also be the weak remnants of the tropical cyclones. They can be weak remnants of tropical cyclones that can be dragged polewards. They are weak remnants of tropical cyclones. They are weak remnants of tropical low pressures, tropical cyclones, tropical low pressures that can be dragged polewards, by Rossby waves. That can be dragged polewards by Rossby waves. So tropical cyclones, weak remnants, they become the seeds. They become the trigger points. Okay, so if you remember, what are the factors that create low pressure? One is the Colorado low pressure even this can start a temperate cyclone. Because this low pressure, agar Rossby waves hai, it can be dragged towards mid latitudes, and this low pressure can become the basis of air mass interaction. So, ये जो clarity hai in the Jerkins model, this clarity was not there. He talked more about the fronts. He talked more about the air mass contrasts. Okay, all of you? So you have now the Fitzroy's model. You have Abercrombie's model. You have two lines on Shaw. You have two lines on Jerkins and what he thinks about low pressure. And finally, you also have the fifth one, which is the baroclinic theory. Now, the अच्छा खासा अब 3 पेज का आंसर हो जाएगा, only theories of temperate cyclones. Is it okay, all of you? ये आप लिख लेंगे आप लोग, all of you now? So baroclinic is what? These are conditions in the vertical columns of air where equal pressure conditions, they do not align with equal density conditions. This is a special case, okay? What happens is the conditions in the vertical column of air. There is a column of air. In the vertical column of air, the equal pressure conditions, where equal pressure conditions, they do not align with. Okay, equal density conditions. They don't align with equal density condition. What I mean by this is, if these are the lines of equal pressure in the vertical direction, equal pressure, okay, then the density lines are parallel to this. Equal density, equal density, equal density, equal density. So equal pressure lines aligning with equal density lines. But what happens is, because of whatever reasons, if these are the pressure lines, the density lines are slant. The density lines are slant. The pressure lines, okay, the pressure lines which are isobars, these are isobars. They don't align with the density lines. And some mechanism, mathematical model hai. This creates the dynamic low pressure. You don't need to write more than this. One paragraph, 3-4 lines with a diagram. This is called as barotropic. This is called as barotropic condition. This is called as the baroclinic conditions. Yeah, I presume many of you would have known this, but otherwise, theek hai. So you've got 4 or 5 models explain how the temperate cyclone develops. Okay. Now, how do you, any question on temperate cyclone, how do you want to end it? And the answer towards applied dimension. Okay. A very important aspect of the temperate cyclone is, I must have good air mass formations. I must have good contrast of air mass conditions. What's happening because of global warming? In the winters, the contrast is becoming very strong. Siberia has become very, very cold, and Atlantic and Arctic are becoming warmer. So MT is becoming more warm and CP becomes very cold. Very powerful temperate cyclones then. Or summers may, the contrast is very weak. In the summers, तो पहले क्या था? Temperate cyclones are throughout the year. Summer intensify. Now what we find is temperate cyclones summers में बहुत कम हो गए हैं, and winters have greatly intensified. And the answer on those lines. देखो right down here. Just the last 2-3 lines. And the applied aspect of temperate cyclone. Applied aspect is the global warming, climate change. Global warming, climate change. Okay, marine waters warming, and extreme winters of Siberia and Canada. Winters of Siberia and Canada, okay, are impacting temperate cyclone formations, with different intensities than usual. So number one, the summer temperate cyclones are few and they are weak. ठीक है? So mild rainfall, यही होता है आपका droughts. Not good temperate cyclones, so not good rainfall. And that's why we have so much of drought conditions in parts of Europe and parts of Canada and US. Next point. The weakening of Rossby waves and the polar vortex. The weakening of Rossby waves and polar vortex slows down west to east movement of temperate cyclones. It slows the west to east movement of temperate cyclones. ये कुछ बताया था कल मैंने आपको? The blocking conditions. Okay, temperate cyclones get blocked and you have got heat waves now. The omega blocking is, yes. Okay, so how they impact? Climate change impacting. एक तो weak हो गया, strong नहीं है, plus वो move भी नहीं कर रहे हैं ज़्यादा. So blocking condition, heat waves, forest fires, you can go on there. Canada में and in parts of Europe. The third is in the winters, the contrast of air masses is unusually very high. In the winters, the contrast of the air masses is unusually very high. Therefore, very powerful temperate cyclones, and not just that. Okay. Now see, what does the polar vortex do? The polar vortex keeps the cold air of high mid latitudes towards the poles. Okay. But when it weakens, it comes down. So साथ में क्या होगा? The temperate cyclones also start coming down. So earlier, temperate cyclones were more limited to northern Canada or parts of Canada and parts of Siberia latitude. Now you find them impacting even the lower mid latitudes. As last year, we had a very bad temperate cyclone as far in Texas also, and unusual snowfall in Texas. Why? Okay, all these are because the polar vortex is now coming down. Add kar lo aap. Okay, the weakening of polar vortex. Allows for invasion of temperate cyclones. The weakening of polar vortex allows for invasion of temperate cyclones. Okay, to low mid latitudes. Such as unusual snowfall in parts of Texas. Unusual snowfalls in parts of Texas in US. Please, I repeat, I'm not dictating an answer to you. ये जो content है, it's a formula conclusion for any discussion on mid-latitude weathers, even part of climate change, or discussions on temperate cyclones. The climate change, how is it changing some of the tropical temperate cyclones, movements and locations? You could do that if you want. That climate change has also increased the time and the intensity of temperate cyclones as part of western disturbances in India. Okay, what has happened this year, right? In the month of June, July, we have got western disturbances. Is unthinkable. I mean, all my life I have studied and I have taught western disturbances over India till as late as Feb, March maybe. And by the time it hits June, okay, the jet stream has gone northwards. Now we are saying, okay, month of July, August tak, it was still over parts of northern plains. वो भी add कर सकते हो, yes. But a polar vortex is nothing but the fast moving polar jet streams and Rossby waves. Vortex क्या होता है? Any spinning air is a vortex. Okay, so towards the poles, the very fast moving polar jet stream, the very fast moving Rossby waves creates that vortex. So for sake of analogy, I say, okay, imagine I have a string with a stone, okay, and I'm spinning. When I'm spinning, पहले stone क्या यहाँ पर था? Start spinning. Can you see the stone rise up like this? Okay, so very fast it goes like this. If I slow down, it starts falling down. When it's spinning very fast, the polar jet stream is towards the poles. Okay, and when it slows down, it starts slipping down towards the mid latitudes. Yes, you can add all of that, Balaji. Yes. In winters, the shift is equatorwards, okay? Where does the warm? Arey, water the warm hai hi na, Arvind. And the global warming is creating more warm Atlantic and Pacific waters. The contrast, whatever we have, is for the land. Water is, okay, high specific heat. Uske upar mein water receives, okay, the warm waters. Okay, I'm done with this. So temperate cyclones, now you can handle. Like all the other topics, you know, the stage kya hai. So you must go back and revise the stages. What are the weather conditions? Okay. What is the tracking and the movement of temperate cyclones? Yeah, add kar lena. So I'm done with this topic. Okay. Now let's move on towards the next topic. A bit of discussions on air mass. Air mass. Yes? 1 minute, sorry. Okay, fine. You know, I know that, but it's just that I do not know the details to be able to teach that to you. ठीक है, you reminded me. Next class, I'll try covering something on that. We'll do that. Okay. Yeah, looking at those 10 marker, once in a while they ask you Halloween storm types. ठीक है. Okay. Let me study that well to teach that to you properly then. Okay. ये सब चीज current affairs में है. Okay. So yes. Okay. I mean, I don't want to teach separately, but please know this concept called medicanes. Medicane is essentially Mediterranean plus hurricane. It is not known to have very powerful ones, but it does have, okay. And this has increased because of increased warming of the Mediterranean Sea. Okay. Medicanes, and iska recent tha, we talked about that. It impacted Libya, the dam burst. So yes, the Mediterranean Sea, hurricane of Mediterranean Sea is the Medicane. Okay, let's move on now. Air masses. So say I frame a question like, yes, wet bulb. I don't know. Wet bulb I know as your thermometer for this one, but कुछ condition की बात आप बता रही हैं. Again, I must look up. Yeah, please cross check. I know some of these are there in the news probably. Okay. I'll check up maybe. Okay. Now, say a question like, अच्छा, एक और चीज just alerting you guys, okay? Because you asked me last time and this time also. In the question paper, okay, in the question paper, you'll always have one or two questions you have no clue about. Okay, abhi aap hindsight mein, what's Halloween storm? Hindsight mein, okay, what is speleothems? Go back and look and talk about the phreatic eruptions. Otherwise, it's impossible you could have studied that. ऐसे questions होते हैं. एक question पक्का होगा आपका. वैसे ही मैप में there'll be one or two entries. वो पता भी नहीं है कि इंडिया का है, बांग्लादेश का है, वो लैंड में है, वो मून में है, you have no idea. बट पूछा होता है. And there are 4 or 5 questions which you should know and know it very, very well. 2 questions, these are the tricky ones, very applied. You have to think and write. So what happens in preparation is a human thing. Our focus always goes here. ये नहीं पता, अब मैं क्या करूं? ठीक है? So why did you score bad marks? Sir, no, they asked Halloween storm. My answer is, Halloween storm 10 मार्क का क्वेश्चन था. आप बढ़िया आंसर लिखते, कितना मार्क्स पा लेते आप? Okay, you would have got 6, 7, 8 मिल जाता. Right? On the higher side. Generally, I say beyond 8, it's an ego problem with the examiner. Examiner feels that you will take his job types. Okay, so 8 मिलेगा आपको. आपने लिखा नहीं, तो 8 आपका 0 हो गया, यही हो गया ना. You are a topper, no? Topper, you should have scored 290 marks. -8 कर लो. Okay, 282 ले आओ. भाई ये Halloween storm के लिए, why will your marks come to 230? I hope you got the point, all of you. वैसे ही, सर मैप खराब हो गया. ठीक है, मैप खराब हो गया. 2 क्वेश्चन है. Okay, maybe 5 मार्क के 4 मार्क, whatever. आप लिख के मार्क करके कितना पा लेते? Okay, 4 में से 3 मिल जाता, 3 मिल जाता, 6 मार्क मिल जाता, 6-0 हो गया आपका. तो I can't explain why you should get 200, 230, 240 because of those 2 entries. Sir, I got nervous. Then my answer is you deserve not to qualify then. अगर एक क्वेश्चन दे के आपकी पतून खुल गई और आप वहीं गीले होके बर्बाद हो गए, what will you do with administration? Okay. So what happens is we tend to focus on these a bit too much. And the problem is, बेटा ये ऐसे सवाल हैं, ये दोबारा रिपीट कभी नहीं होने वाला. You prepare Halloween storm, they will ask you Diwali typhoon. You prepare Diwali typhoon, okay, they will ask you Imphal ka rainfall, some local name there. It's like you are in a wild goose chase. ऐसे क्वेश्चंस को हम मुड़ के देखते भी नहीं है. पूछने दो. My question is, ये जो पता होना चाहिए था 4-5 क्वेश्चन, इसको कैसे लिखा आपने? If others can write 5 out of 10, you better write 7 out of 10. That competition is there. Others इसको छू नहीं पाए because they got confused. आपने क्या किया? Did you touch these questions? You touch it. These will fetch you very good marks. इसमें ना examiner बोर हो चुका है. In this, the examiner will look for what did you not write. मेरे मन में, see, if I ask you, if you give me a question on, write a note on temperate cyclones, the weather and the stages. पूरा answer छपा हुआ है दिमाग में मेरे. I exactly know what the answer must have. So when I'm checking कि क्या छोड़ रहा है. Okay, ये तो होना चाहिए, ये भी नहीं है, ये भी नहीं है, बाकी यार ठीक है, ये भी तो नहीं, ये भी नहीं है. It's like I'm checking for what you have left and I'm giving you marks according to that. In this question, the examiner has no clue कि आप क्या लिखोगे. So this one, whatever you write down, if justified well, he says is great. This is a very nice development, a very nice answer writing skill. So yahan par is difficult to cross the threshold marks. These questions will help you maintain the marks. These questions take your marks, they shoot you up. Or if you solve these questions, it's actually bad news. You know why? भाई इतना आपने इतना बकवास पढ़ा हुआ है कि मेन चीज छोड़े हुए हो आप. You are so much into peripheral study, the main study is gone. So stop getting bothered about these type of topics. Okay, in the map pointing, same technique. There will be 1 or 2 entries you have got no idea about. Don't kill yourself there. But you must know Sanchi. You better know, okay, Namdapha National Park. You must know, okay, where do we have Alwar or Sambhar Lake. You better know where is Wooler Lake. And some XYZ entry, chhod do usko. I hope you got the strategy, all of you here. So while you ask me all those terms, I look up, unless it's really, it's like Medicaid, I say it's the important one. Kafi news mein raha hai, discussion hai, such big scale devastation. I think it's possible, but not every random new topic. Okay. Anyways, just to alert you guys, don't get carried away by these questions. Focus on these questions. Okay, come back to our air mass discussion. Okay, air masses. So write the question down. Write the question down. How do air masses impact weather and climate? How do air masses impact weather and climate in different parts of the world? In different parts of the world. Discuss with examples. Discuss with examples. And explain the mechanisms associated. Okay, so I hope you appreciate. This is not a question you can say कि नहीं पता है, right? I'm giving you 3, 4, 5 minutes. Think through this and give me the storyline structure of this question. कि आपका answer कैसे लिखोगे? Harshita, don't do that. Okay, I want the entire storyline. Okay, those 6 boxes. पहले box में क्या? Second में क्या? Third में क्या? Tell me what diagram you can draw where. Okay, go on. I don't want an answer. I want you to give me the structure. How do air masses impact the weather in different parts of the world? Okay. Explain with examples and mechanisms. When I say different parts of the world, do you realize this will be a list of weather phenomena now? और कल मैंने क्या कहा था आपको? जहां पर आपका लिस्टिंग वाला पॉइंट्स आएगा, you always write in context of the specific examples, correct? So पहले काम करो on the margins. Make a list of what are those air mass weather impact. Make a list of that first. Give me examples of what are the impact of the air mass. How does air mass impact the weather? Give me a list. Temperate cyclones, okay. Temperate cyclones. What else? Yeah, sorry. Arctic smoke, a leak effect. What else? Front formation. What else? Affects ocean currents. Okay, fine. Affects ocean currents. Altering winds, inversion. Altering winds, inversion. Anybody else? Instability. और बताओ? Newfoundland fogs. जितना भी पता था सारा बता दिया आपने, ठीक है. Newfoundland fogs. Impact of climate on North India. Impact on North India. Tushar, I gave you one exercise. Give me a list of how do the air masses impact the climate. Give me examples or give me some instances of that. Norwegian sea impact. I don't know what you mean by that, but ठीक है, लिख बोल रहे हो तो लिख लेते हैं. Norwegian sea impact of the CP. Okay. Urban heat island. तो आपने ट्रोपोस्फियर और स्ट्रेटोस्फियर का लेयरिंग क्यों छोड़ दिया? वो भी ऐड कर लो. Yeah. Can you realize what I have done on the board? क्या किया बताओ? Why have I kept this column separate and this column separate? Yeah? Yeah. These are the generic ones. Temperate cyclone in general, fronts general, ocean currents in general, alter winds in general. ये specific है. Arctic smoke very specific. Lake effect very specific. हालांकि ये इतना सही नहीं है, but ठीक है, specific है. इसमें क्या लिखोगे? I do not know. So give me some specific ones. We're talking about temperate cyclones, right? Can you mention a specific one? Then I know you have understood that part. You were discussing. Yes, very nice. Now you have come to specific, the British climate. Okay. Give me specific ones. Heavy rains appellation is part of the lake effect. Manchurian is a bit too far dragged one. The impact of northern India hai, say western disturbances. Frontal interactions and air mass. Okay. The cold waves from Siberia impacting Central Asia. The cold winds from Western Europe, central regions. Sahara se, that's more in terms of the local heating that creates Sirocco Khamsin types. Isko air mass mein na rakho. Okay. Chinook is not a consequence of an air mass. It's the consequence of a local wind. So local wind ko hata do yahan se. ठीक है? So now your discussions will be on these. Now on these, the mechanisms are air mass or movement modifying as air masses move out. Air masses, interactions, creating fronts. यही दो मेन आपका मैकेनिज्म है. Thermodynamic modifications and frontal modifications. Okay, so this is not a very good way of explaining. Get into this. Geography requires more and more of diagrams. It requires more and more of, okay, examples and details of the phenomena, not superficial ones anymore. So your typical structure will be this. Start with air masses as important concepts to explain mid-latitude weather. Define kar lena large bodies of air. Okay. You can talk in the context of air mass, source regions and the properties. Sab kuch, not more than say 2, 3, 4 lines, whatever you can. Okay. Then you move towards something on a diagram. It could be a schematic. It could also be a map of the world showing some of this. Look at this. Now, mujhe ye sab dikhana hai na. I'll show all of this. So what I can do is, I can probably draw the map of North America and I can show maritime tropical air mass impacting the weather of the Atlantic coast. Okay. I can show CP Canadian moving like this and we have the lake effect. I can show the Canadian air mass impacting with maritime polar, okay, creating fronts. This is the temperate cyclones. So, isi map mein, I've shown you 3 types of air mass consequences. So, this air mass impacting the east coast of US, this interaction giving me the fronts and temperate cyclones, and this giving me the lake effect. So, 3 examples of how air mass can impact the weather of North America. Make a list. Okay. Warm, humid climate of eastern US because of maritime tropical air mass. A lake effect of the US because of CP moving over Appalachians. Temperate cyclones because of CP and MP or MT interacting. ये आप डाल दो डायग्राम में. Your diagram should be something that tells me about the question asked. या तो ये करो or try a schematic. Okay, so this I repeat, MT because Azores high hai. The Azores high, MT, it is warm, moist, impacts the east coast of US, moderates the climate of the Atlantic seaboard. Okay, the CP Canadian in the winters, while moving towards Great Lakes, you got the lake effect of the Appalachian windward side, or western side. The Canadian air mass interacting with maritime polar of the northern Atlantic, giving us this. You can also add here if you want to add. You have the Arctic air mass moving towards the Norwegian Sea, and you have got Arctic smoke. जितना दिखाना है, 2-3 दिखा दिया आपने. That what is an air mass, what does it do? What's an air mass, what does it do? And diagram में you have illustrated the impacts. No, Pratibha. You have to practice these things. These things will not happen automatically. That's why I'm teaching this to you. आपके answer में, okay, go back to your room and practice this, all of you. कि कैसे बनाएंगे आप? Open up. So I'll show you one page for all of you. Air mass coming year May is going to be very important. They've not asked for 2 years. So no, I cannot. Okay, I will encircle this for you. In your climatology by Savindra Singh, page number 213. This diagram you can simplify and reproduce. Page 213. Maritime tropical Pacific air mass. It moves and moist conditions here. The tropical air mass, dry conditions, warm conditions. The maritime tropical, okay, maritime tropical, they bring warm, humid climate along the east coast. The CP air mass, Canada, cold, dry winters comes down, and you have the lake effect here. Okay, and this interacting with this here can create. So, ये diagram बना लेना आप लोग, and tell us dry, moist, wet conditions you're on. ठीक है? So this one, I'll suggest you practice this one. Okay. इसके अलावा, now the body of the answer starts. Now in the body of your answer, diagram body में, you take specific examples now. Start with temperate cyclones of Siberia, okay, of Canada, and how the temperate cyclone impact the British type of climate. CPMT impacting warm front, cold front. You can go on there. You can draw this diagram of, okay, the fronts are moving, sea, warm. What type of weather here? What type of weather here? This is one example done. The second one, explain the lake effect. Explain the lake effect. Okay. Third one, explain Arctic smoke. Okay, how the continental Arctic air mass, CA air mass, moves over Norwegian Sea, and how that converts into CPK instability, and you have got the fog formations. Fourth, you remember the cold winds called Bora, Gregale, याद आ रहा है आपको? वो कैसे बनते हैं? Because in the winters, the Western Europe, it becomes very, very cold. Very cold, high pressure. That becomes an air mass. And because of divergence from the Central Europe, the cold winds are moving out towards north and south. So south wale hain towards Mediterranean, because in comparison to Europe, Mediterranean is low pressure. Okay, so this is so you have the high pressure, this continental polar air mass, and from here you got this is anticyclones. So yahan se winds like this and like this, moving like this, and the Mediterranean is relative low pressure. So from this air mass, okay, this movement starts towards the south, okay, high towards low pressure, and these create the local winds called as Bora, the local winds called as Gregale, the local winds called as Meltemi. Meltemi in Turkey, Gregale in Greece, and Bora winds in parts of Adriatic. In parts of the Adriatic. Okay? Okay. Next is the same type of phenomena we also have for Siberia. The same thing for Siberia. Siberia, this is the continental CP of Siberia. And when this starts moving down south, the Central Asian part, this has cold waves. हम बोलते हैं ना कि Himalayas अगर नहीं होते, then India's weather would have been very different, because these cold waves would have invaded parts of India. ठीक है, हो गया आपका आंसर. Okay, one temperate cyclone, one was lake effect, one was okay your impact on Arctic smoke, Europe and cold winds, Siberia and cold waves. The examples are done. Yes, absolutely, you can add that also. And end the answer towards how air masses are getting modified because of climate change. Then you're on. Blocking भी एक type of climate change है. I told you contrast increasing वो भी एक type of climate change है in the winters. Try and write, Aman. These answers should not cross more than 2.5 pages. With diagrams, you struggle for 3 pages. Try and write. So explain one diagram, series of explanations with diagrams, and the conclusion. Okay. The last question. Take the question down. Explain how Thornwhite's potential evapotranspiration concept. Explain how Thornwhite's potential evapotranspiration concept was a marked improvement over Köppen's climate classification basis. Köppen's climate classification basis. Also discuss, that explain how the potential evapotranspiration concept of Thornwright was a marked improvement over Köppen's climatic classification basis. Also explain, also explain what are the factors that impact potential evapotranspiration. What are the factors that impact potential evapotranspiration? And how is it measured? आप देखोगे लास्ट 5-6 साल में, the main questions on climatic classification is around PET. And otherwise, the rest of the questions are straight. Köppen classification क्या है, Thornwright क्या है, Thevarta क्या है. Your class notes can handle it. But this is very specific on PET concept. What is it and how did he improve on the concept of Köppen? Okay, so I'll explain first, then I'll come back and tell you what the answer may look like. Okay. Now, you first have to understand what PET is. PET essentially is a measure of relative aridity in terms of precipitation and temperature. It is a measure of relative aridity in terms of precipitation and temperature. ठीक है? That's one point. कि ये क्या measure कर रहा है? ये aridity को measure कर रहा है. How dry a particular place is. It is an attempt to establish how a temperature and rains impact vegetation types. How temperature and rainfall impact vegetation types. Because for both Köppen and Thornwright, vegetation basis was the primary. Vegetation basis was the primary, a method of climatic classification. ठीक है? So मुझे करना क्या है? Climate को classify करना है. To classify the climate, I'm using vegetation, and until I find how vegetation is linked to temperature and rainfall, the classification will not be correct. This is the whole idea why I'm so particular about it. Okay, now in Köppen's classification, a vegetation was decided on the basis of the concept of precipitation effectiveness for the relatively dry areas of the world, essentially for the B type. In Köppen's classification, what he did was, vegetation's relationship with climate was established in terms of precipitation effectiveness, where precipitation effectiveness was essentially P minus E. P minus E for all the relative dry areas called B, okay, where evaporation was more than precipitation. I think you all know this part. That's what he did. That's what Köppen did. Now, in this Köppen, okay, relies on the actual evaporation losses as a measure of aridity. He relies on dry areas of the world. So Köppen relies on the actual evaporation as a measure of aridity. अच्छा, ये जो actual evaporation है, this is according to Köppen. According to Köppen, the actual evaporation is related to temperature alone. That was his idea. Okay. So for Köppen, the evaporation is related to temperature alone. But can you tell me what all factors does evaporation depend on? Temperature is one of them. What else? It'll depend on winds. It'll depend on relative humidity. It'll depend on amount of soil saturation. Kitna soil mein pani hai. Okay. So just, yes, soil type. So just saying evaporation is a function of temperature is giving us a wrong idea about evaporation. You're giving a wrong idea about the type of vegetation. Write down in this, Köppen ignores the role of, take 1, 2, 3, 4. Köppen ignores the role of winds, relative humidity, okay, soil saturation and soil type, and soil temperature. Okay. So Köppen's classification of dry type of climate. So Köppen's classification of dry type of climate on the basis of evaporation alone is not a good representation. So what is the concept? Measure of aridity. Why do we need that? And what has Köppen done? Okay, for Köppen, evaporation is the most important one. Now give a subheading. How does Thornwright improvise? How does Thornwright improvise? Okay. Now Thornwright does 4 things. How he improvises is 4 things. Number 1, he acknowledges that evaporative losses must also include transpiration losses. Evaporative losses must also include transpiration losses from the plant's stomata and cuticle. From the plant's stomata and cuticle. C-U-T-I-C-L-E, the layers of the stem, stomata and cuticle. Now see, this is basically what I'm saying is loss of moisture. Loss of moisture. There are evaporation losses and there are transpiration losses. Evaporation losses from the land, evaporation losses from the oceans and water bodies, evaporation losses, okay, from the plants. जो plants में जो droplet हैं, they are evaporating. ये transpiration नहीं है. There could be some droplets on the plants that evaporates. Okay, and evaporation also from the soil. And transpiration is from the plants, stomata and cuticle. These are the 6 components of evaporation losses. So for Köppen, it was largely this alone. Okay, he is not considering soil, he doesn't consider plants losses, और ये तो उन्होंने किया ही नहीं था. This was one aspect. कि Thornwhite, what he did was, he started acknowledging that this also is important part of evaporation loss. Fine, all of you? That was one. Number two, Thornwhite gave the concept of potential losses. Thornwhite gave the concept of potential losses, which is losses in the conditions of soil moisture saturation. Losses in the conditions of soil moisture saturation. So when we add enough moisture, now let us see how much is lost. Not simply जितना है उसी से निकाल रहे हैं हम लोग. So when Thornwhite does that, Thornwhite is adding this also. Okay, and when you saturate the soils, okay, ये तो add हो ही गया. Whatever water bodies might have, and somehow this also gets accommodated. But ये important नहीं है. Why? Because I'm talking about vegetation. So I can as well ignore this for now. And इससे ज़्यादा important ये वाला concept हो गया. So Thornwhite is able to add the soil moisture conditions also. ठीक है? Okay, the third one. Rather than, next point, rather than recording evaporation, Thornwhite relies on field empirical studies. Thornwhite relies on field empirical studies. So field experiments से क्या उन्होंने? Relies on field empirical studies or field experiments. Now see, when you are doing a actual experiment on the field, do you realize automatically he's also accounting for, okay, moisture saturation. He's automatically accounting for maybe the local winds also there. आपके equation में याद है? There are some, okay, figures like I, A, complex number याद आ रहा है? So all of those number gets accommodated. It's not a simple कितना evaporation हुआ. In the field conditions, he's taking that. Write down this point. In the field experiments, he was indirectly able to incorporate. He was indirectly able to incorporate the role of relative humidity, the role of soil temperatures, and soil saturation conditions. Hence, his complex formula of PET, is more comprehensive calculation, and not merely depending on evaporation recording instruments, There are two instruments for recording evaporation. There are two instruments. One is called as photometer. एक और है, for plants we use lysimeter. Lysimeter records transpiration. Okay, ये instruments हैं. You can put water and see evaporation and record it down. Okay, photometers, POTE, photometers and lysimeter. These are two instruments. But what he does is, okay, these instruments may be Köppen had used. He had used photometer for evaporation recording. But Thornwhite does a different approach altogether. He's on the field and studying, okay, what is the amount of water left behind because of actual conditions of saturation. Okay, so you could have a small box. Okay, factors that affect evaporation and transpiration. मैंने बताया आपको. One is temperature, one is soil moisture, soil saturation, relative humidity, also the presence of winds. And what are the instruments, or what are the methods of calculating evaporation and transpiration? So we can use photometers, we can use lysimeters, we can have soil saturation studies, we can have soil experiment field studies, soil saturation studies and soil experiment field studies. So some techniques are there, we picked those up. And of course, I forgot one more, the study of water balance. These are some techniques which have been used. Study of water balance. So Thornwhite, Köppen relied on this. This was Köppen's approach. Thornwhite relied on these. Temperature, soil moisture, soil saturation conditions, relative humidity, and winds. Instruments and methods: photometer, lysimeter, soil saturation studies, soil experiment field studies, ये artificials वाले होंगे, and water balance study. So Thornwhite did not use or did not depend on these two. Okay, Köppen focused on this one, and these methods were used by Thornwhite. And all of you? Right, next. It is because of the detailed approach of Thornwhite. Because of detailed approach of Thornwhite in experimental and actual soil saturation techniques, Thornwhite was able to give a more realistic understanding of how vegetation is linked to climate conditions. How vegetation is linked to climatic conditions. All done here? So this is almost like an answer for you. Isko modify karo ab. All the content given to you, method given, factors given, techniques given. Go back and check how many questions asked on this and whether you can answer that question now or not. Don't go beyond this. The graphs not required. Okay. Now a quick assessment of the coverage. Now see, please, all of you. Heat budget of the earth. Your straight questions, L1 type ही होंगे. Atmospheric stability, instability, the graphs, straight your class notes, whatever your, and anybody kahin se bhi kiya ho. These are the basic ones, you should have it. Okay. Local winds, okay, you can handle. Monsoons, for some of you have not done because of paper 2 not done. Otherwise, jet streams, there are no tricky questions. Straight questions, jet streams, what are they, how they impact? Air masses, I've given the additional points for you. Fronts, tropical cyclones straight, temperate cyclones I've added. Okay. Now, atmospheric circulations, okay, fine. Weather, climate, no big deal here. Now, yahan par, Thornwhite, I went in a bit more depth here, Thornwhite. Now, no questions up till now asked on temperature and pressure belts. But my suggestion, jo aapke L1, L2 discussions hain class notes mein, what are those zonal belts? What are seasonal cells? Wahi kaam aayega aapko. Now, this I think I've covered in good detail now. Hydrological cycle. Precipitation pattern ka disruption kya hai? This we have done in the last class. What is general pattern? You know that. The disruptions are, we talked about blocking. Disruptions are intensified hurricanes. Disruptions are El Nino related disruptions, triple dip, La Nina. Bring in all, okay, current affairs wale discussions. Okay, global climate change, wo ka bata diya aapko maine. Talk about, okay, Arctic amplification, what it does, gave you some data on warm temperature, precipitation, cryosphere. And for conclusions, I've given you something on what all we are doing. Now, a response of urban climate we have done, that urban heat island. Response of man in climate change. See the older batches, this I have not covered in your regular class. But the current batch, I have done this in the regular batch itself. Because now I think they can start asking more applied here. So I'll just give you one format and then we are done on this. The format is, if they ask you, what is, and this can be in any domain, not just climate change. What are the, ये format है आपका, the human response to climate change. I'm giving the format to all of you. Okay. Now, there are two aspects of human response to climate change. One is whatever we are doing under mitigation efforts. You know all of this, just putting in a format. And whatever we are doing as a part of adaptation strategies. Mitigation efforts, these are addressing how to stop or how to reverse climate change by focusing on the root factors. By focusing on the root factors. The root factor is there are emissions. The root factor is that we have problems of deforestation. The root factor is that we are constantly modifying the urban environment. So root factors are those which create the climate change जो हमारे हाथ में है. Okay, so all efforts at afforestation programs, all efforts under Paris deal, उसके पहले whatever we did under Kyoto Protocol, okay, whatever we are doing as a part of controlling emissions, okay, the target is that we want to keep our temperatures within 1.5 centigrade and worse come worse 2 centigrade over the pre-industrial temperatures. तो जो कुछ भी हम इसके लिए कर रहे हैं, okay, they are all about mitigation. Okay, so very specifically, we're talking about net carbon neutrality. We are talking about 30-30 याद आ रहा है कुछ by 2030. Okay, you have talked about International Solar Alliance. So in geography, you don't have to have the entire range. Whatever you can add from this much, it's good enough. What's our response? What am I doing to respond to climate change? The very and do add. India talks about the concept of life. As I have not discussed in the optional class, in the GS class, I had given some ideas. So I'll just mention a few words and I'll move on. Okay. Dekho, what does life actually do? Whatever ideas we have in life is essentially what? Now, let us not have mindless consumption. Let us have wise, thought-through utilization. Let's not be energy intensive. Let us be energy efficient. Let us manage our lifestyles, the way we use water, the way we consume energy, the way we make our houses. So whatever you see under life is very much a part of a sustainable development. इसमें कुछ नया नहीं है, वही चीज है. फिर different क्या है? Like whatever I tell in life, okay, use energy efficiency, don't waste power, conserve the water, let's not pollute, let's try to make urban areas better. जो भी आपके objectives हैं, all of them are more or less sustainable development. फिर life में, okay, what is new here? What's new is that life talks about how as individuals and how as communities we can change our behavior. This is more of a development approach. And these applies to the countries. It applies to nations. Whose answerable is the government. Okay, this is a much, much larger scale. Life says कि at the individual level आप बताओ क्या कर सकते हो? Because all of this will not work till we as people change our behavior. Till we as people stop using plastics. Till we as people learn to switch off the fans on time. till we as people stop using cars and vehicles and rely more on public transport. So life is about the individual's behavior change. And if this can happen, now this can make the governments more accountable. Okay, if this can happen, then the people become the pressure groups. Then the people become the lobby groups here. Yes, at the micro level, individual level. Yahi difference hai. So how are we responding to climate change? Ek naya philosophy bana, where you're focusing on individual level engagement as a part of personal responsibility. So that as individuals, we can ask the government to respond. Then we will decide who to vote for if environment not taken care of. So we decide the priorities of the government. That's the whole idea. Okay, so add something, whatever you can. Response. The second part is, what is our adaptation strategies? Iske 5 component hain. Adaptation strategies, agriculture and crops mein. Adaptation strategies in case of disaster, okay, interventions like evacuation, relief, and so on. Adaptation strategies in terms of rebuilding infrastructure. So you know about a CDRI approach of India, okay, climate disaster resilient infrastructure, okay, CDRI, agriculture, okay. Now adaptation strategies, okay, it's also about managing water resources, khaskar rainwater harvesting, okay, talking about watershed development, okay, and adaptation also includes change in lifestyles. So we have to adapt to our changing conditions. ये 5 component है for adaptation. I repeat, agriculture may change, what type of crops we grow, the harvesting seasons, the research development in drought-resistant varieties, how we intervene in disasters, because I know so in interventions, I also include managing migrations. I think आज के paper में है, the country called as Tuvalu, I think. Tuvalu is considered to be the first officially declared nation which will submerge because of climate change by before 2100. Okay, आज के paper में I read Tuvalu is considered the first island to disappear. Okay, that's about managing. ये लोग कहाँ जाएंगे? Where will they go? They must tie up with some countries, some laws will be managed, changed there. That's part of adaptation, migration strategies. Then we have infrastructure redevelopment. Okay, talking about water management and change lifestyle. इसी में आप add करना as a part of adaptations to make all of this happen. You know about loss and damage fund, COP 26 and even 27 has talked about it. Loss and damage. Yeah. Yes, absolutely, Arvind. You can write down. One example, a case study of adaptation is Indonesia shifting its capital from Jakarta to Borneo. Absolutely, yes. The example of adaptation strategies will also be your green wall. Okay, green wall of India, the green wall of Sahel. Yes, the adaptation, now specifics mein, the adaptation includes encouraging millets. Adaptation includes green wall construction. Adaptation includes redesigning cities and urban areas. Okay, we can look into some kind of climate change risk insurance. So this is one topic not asked. I think this will be important topic to prepare for. Lot of current affairs, but here aapka format. The format of how are we adapting to climate change, okay, issues. Wait, don't go. I wanted to start oceanography. Okay. So at least let me give you the question. By the way, all of you, now listen. You on Sunday, you have your practice test. Okay. Now see, this is yes, Manoj, you can add all of that. Now please, it's like almost like a request, almost like a what? Appeal. Okay. Don't shy away from any tests. आप अगर टेस्ट नहीं देते हो, believe me, सबसे अच्छा मेरा है. आप टेस्ट नहीं दोगे, मुझे चेक नहीं करना है. I don't have to have the headache of giving inputs also. It's very nice for me. Okay. But that is not why we are here for. Irrespective of आपका कितना पढ़ा है, नहीं पढ़ा है, and those who have joined me late, you also give the test. Then the general answer is, sir, exam खराब हो जाएगा. My retort is, let us see कितना खराब होता है. ये पता होना चाहिए ना. सर मेरा प्रिपरेशन नहीं है. Then go back and check कितना खराब प्रिपरेशन है आपका. So do not shy away from any test, please. So it's like a request here. So this is what we have now. On Sunday, you have your first practice test. In practice test, we'll give you 10, 12 questions. There are no surprise questions. I will ask this from the 20 questions we have given you. Okay, एक हमने दे दिया है. Another one शायद हो चुका है. Go back and check. Another 10 of them. हम इसी से ही पूछेंगे practice test. The whole idea is you have to start writing now. To wait, sir, अच्छा answer बन जाएगा. I will learn answer writing and then give the test. My answer is no. Give the test or dete you will learn answer writing. Okay. So all of you on Sundays and again, those joined me late, this test will not be evaluated. Why? Because मैंने आपको answer दे रखा है. I've told you what the questions are. Okay. The questions will be from what I have taught in the class. Today, I think I've covered what? 3 or 4 questions. कितना करा है मैंने आपका? Whatever we have done. Today, I've done yesterday and on Monday. In totality, I must have covered about 10, 12, whatever topics I've covered now. So last from these questions, you make your answers plus whatever I've given you. हम इसी से पूछेंगे आपको. Okay. And I've ensured that through these questions, the entire syllabus is touched. एक क्वेश्चन इन्वर्जन पे है, विंड में है, साइक्लोन्स पे है, एयर मासेस पे है, जेट स्ट्रीम्स पे है. There are 2-3 previous questions also. Okay. बहुत होता है. These 20 questions plus I've discussed 10, 12 more. 30 का answers आपके पास है now. And good, right, nice, rich content. You have today, you have got tomorrow. Okay. On Sunday, whatever time they have told you, or you can talk about it and give the test, please. Give the test and you yourself know how good or bad you have done. The challenge in the test is you have to finish the answer writing within 2 hours. All questions. If somebody says, ek bhi chhuta hai, so then you have not got the speed right. All questions, no choice, with diagrams, with current affairs, जो भी important है, you'll do that. ठीक है? So let's do this, and you will feel better with a sense of completion. Okay, we did the foundation class. We have done the 2 or 3 classes in the enrichment. You have 30 questions with you now. Okay, the foundation guys, you must have done your workbook or synopsis, whatever, and you are done with it. Okay? So that's my request to all of you. Which newspaper? Shweta, I think this morning I read something on Hindustan Times probably. Google search kar lo, mil jayega aapko. Not a big deal. Okay, the Tuvalu question. Acha, now, what I want is, your next class is on Tuesday. Before you come on Tuesday, I'll start off with oceanography. I am one class behind schedule now. In oceanography, again, same things. Please finish synopsis. आपके पास Sunday बचेगा, Monday होगा, and older students, you also have the Tuesday mornings. जितना कर पाओ कर लो. In your foundation classes, I have given you 10, 12 answers of oceanography, the older batches. Okay, the new batches, I'll give the answers to you maybe on Sunday. You have to memorize this. Okay, please look up the PYQs and we'll start off with analysis. Time of the test, क्या time दिया आपको? 4 to 6 in the evening. Yes, so 4 to 6. But I can give the question paper earlier also. Okay, घर में है तो कर लीजिए आप. But I'll prefer, okay, if you can follow that, okay, strict time regimen, all of you. Okay, fine. It's time now. So give your test on Sunday. We'll have a conversation thereafter. Memorize, all memorize. Achha, one request to all of you, online and offline. We would like to get your feedbacks also of all the classes that you have with the GS or geography, whatever, MSP. So on the portal, we have put up a rating and feedback column. All of you, please give your feedbacks there. Okay, it is for our internal assessment of what we can do better. So online, offline, both. We don't have too many responses there. Please do this. What are your questions? Santosh, how are you? I'm good. Okay. I'm told I have grown a bit more handsome these days. Okay. But I don't know. You will come and tell me. Yes, Manoj, correct. Himanshu, Decandol, yes. You want to talk to me? My phone number is this. Rahul, I'll manage that. Don't worry. Nashit ho jana chahiye tha. Go back and check. You have taken geography optional. Very nice. So we are game. Rahul, if I don't pick up the phone, I'm busy. Otherwise, it's all good. No problem. Bye. My wishes to you, RKY, Yogesh. Yogesh, blessings, my wishes. Stay happy, stay healthy. I can work sincerely.